Hey everyone, welcome to the blockchain and cryptocurrency course. In this video tutorial, we will be learning about blockchain and how it works, in which we will cover distributed ledger and how it works, blockchain and its basics. So let's get started. Distributed ledger. You know now what is digital ledger. If you haven't watched video of ledgers, please pause this video and go through it first. If we mix decentralized architecture with digital ledger, we can make ledger distributed. In decentralized architecture, all nodes store a copy of same ledger. All nodes have some level of access to the ledger. All nodes agree to a protocol that determines the true state of the ledger at any point in time. The application of this protocol is sometimes called achieving consensus. As you can see in this image, all nodes are connected to its peer nodes. Now, when someone broadcasts transaction through one of the node, transaction details are transmitted through all other nodes and they validates it. If it's a valid record, then it's stored on ledger. So this is distributed ledger. Now let's jump into basics of blockchain. Blockchains are incredibly popular nowadays. But what is blockchain? How do they work? What problems do they solve and how they can be used? Like the name indicates, a blockchain is a chain of blocks that contains information. This technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents so that it is not possible to backdate them or to tamper with them, almost like a notary. However, it went mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create digital currency called Bitcoin. A blockchain is a distributed ledger that is completely open to anyone. They have an interesting property. Once some data has been recorded inside a blockchain, it becomes very difficult or impossible to change it. So how does that work? Well, let's take a closer look at a block. Each block contains some data, the hash of the block and the hash of the previous block. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores details about transaction in here, such as the sender, receiver and amount of bitcoins. A block also has a hash. You can compare a hash to a fingerprint. It identifies a block and all of its content, and it's always unique, just as a fingerprint. Once a block is created, its hash is being calculated. Changing something inside a block will cause the hash to change. So in other words, hashes are very useful when you want to detect changes to blocks. If the fingerprint of block changes, it is no longer the same block. The third element inside each block is the hash of the previous block. This effectively creates the chain of blocks, and it's this technique that makes blockchain so secure. Let's take an example. Here we have a chain of 3 blocks. As you can see, each block has a hash and the hash of the previous block. So block number 3 points to block number 2 and block number 2 points to block number 1. Now the first block is a bit special. It cannot be point to previous block because it's the first one. We call this the Genesis block. Now let's say that you tamper with the second block. This causes the hash of the block 3 to change as well. In turn, that will make the block 3 and all the following blocks invalid, because they no longer store a valid hash of previous block. So changing a single block will make all the following blocks invalid. But using hashes is not enough to prevent tampering. Computers these days are very fast and can calculate hundreds of thousands of hashes per second. You could effectively tamper with a block and recalculate all the hashes of other blocks to make your blockchain valid again. So to mitigate this problem, blockchain have something called proof of work. It's a mechanism that slows down the creation of new block. In Bitcoin case, it takes about 10 minutes to calculate the required proof of work and add new block to chain. This mechanism makes it very hard to tamper with blocks, because if you tamper with one block, you will need to recalculate the proof of work for all the following blocks. So the security of blockchain comes from its creative use of hashing and proof of work mechanism. We will learn more about this mechanism later. But there is one more way that blockchains secure themselves, and that's by being distributed. Instead of using central entity to manage the chain, blockchain use a peer-to-peer network and anyone is allowed to join. When someone joins the network, he gets the full copy of blockchain. The node can use this to verify that everything is still in order. Now let's see what happens when someone creates a new block. That new block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. If everything checks out, each node adds this block to their own blockchain. All the nodes in the network create consensus. They agree about what blocks are valid and which aren't. Blocks that are tampered with will be rejected by other nodes in the network. So to successfully tamper with the blockchain, you will need to tamper with all the blocks on the chain, redo the proof of work for each block, and take control of more than 50% of the peer-to-peer network. Only then and then you will be able to tamper the blockchain. This is almost impossible to do. So now you know what is blockchain and how it works at basic level. So let's quickly revise what we have learned in this tutorial. We have learned what is distributed ledger and how it is used in blockchain technology. We have also seen what is blockchain and how blockchain works. So this was very basics of blockchain. In further tutorials, we will learn more about blockchain. Till then, stay tuned for next video. Thank you very much.